If you signed a 30-year mortgage on a house in the last decade, your windows are already failing. You may not see it yet, but inside the sealed edge of every double-pane window in your home, a chemical process is underway that the manufacturer knew about, the builder ignored, and the warranty was designed to outlast by exactly nothing. Some industry estimates suggest 22 to 25% of double-pane windows may show signs of seal failure by year 5. By year 10, that number may climb as high as 68%. In extreme climates, coastal Florida, high-altitude Colorado, the freeze-thaw cycles of Michigan, failure can begin as early as year 2 or 3. Your mortgage is 30 years. Your windows are engineered to last 10 to 20, and often considerably less in practice. In this investigation, we are going to walk through the exact engineering reason your windows are failing, the corporate ownership structure that made it inevitable, the warranty language designed to leave you with nothing, and the specific products that will actually last. Starting right now, they call it a double-pane insulated glass unit. We call it a sealed gas chamber with a clock built into the adhesive. Here is how the window industry arrived at this moment. Before the year 2000, residential windows were built with steel-reinforced spacer bars, thick polyisobutylene primary sealant, and wood or aluminum frames designed for a 30 to 40-year lifespan. Annual failure rates ran between 0.5% and 1%. These were not extraordinary windows. They were simply built to a standard that assumed the homeowner would still be living in the house 20 years later. Then, the volume builder era arrived, and with it, a calculation that changed everything. Window manufacturers discovered they could save $25 to $40 per window by switching from steel spacers to thinner aluminum and foam spacers, reducing the thickness of the polyisobutylene sealant layer, and automating assembly lines to run 20 to 30 units per hour. Multiply that by the millions of windows installed annually in American new construction, and you are looking at hundreds of millions of dollars in annual cost reduction flowing directly to manufacturer margins. They call this value engineering. We call it the deliberate shortening of your window's lifespan, priced into a replacement cycle that generates 3 times the lifetime revenue of the old model. The golden era of residential windows, roughly 1970 to 1995, produced homes where 1 or 2 window replacements over an entire lifetime was the norm. In the post-2010 model, the industry expects 3 to 4 replacement cycles per home. That is not an accident of physics. That is a business plan. But the business model is only half the problem. The engineering failure hiding inside your sealed glass unit is even more specific and then more damning than the economics. Let us walk through exactly what is failing and why. Every double-pane window in your home is built around what the industry calls an insulated glass unit, or IGU, 2 panes of 3 to 4 millimeter glass, separated by a spacer bar running around the perimeter, sealed with a layer of polyisobutylene primary sealant on the interior edge, backed by a silicone secondary sealant and filled with argon gas. The argon is what gives the window its insulating value. The target fill is 90% argon. When it works, the unit achieves a U factor, a measure of heat transfer, between 0.25 and 0.35. That is the thermal performance number your builder put in the brochure. Here is what happens next. Your house heats up during the day and cools at night. The 2 panes of glass expand and contract at slightly different rates than the spacer bar. Over thousands of thermal cycles, this differential movement, as small as 0.5 millimeter, stresses the polyisobutylene sealant at the edge of the unit. The PIB rubber is rated for approximately 7 to 10 years of this repeated flexing. After that, micro breaches form. Hairline cracks develop in the sealant layer that are invisible to the naked eye. The argon begins to escape. Argon loss significantly degrades the window's U factor. Your double pane window is now performing at roughly the thermal level of a single pane unit. Your heating and cooling system is compensating. Your energy bills are climbing, and you cannot see any of it yet. Then the desiccant saturates. Every IGU contains a molecular sieve desiccant packed into the spacer bar, designed to absorb any moisture that migrates through the sealant. In budget units, this desiccant is low capacity. Once the seal is compromised and moisture begins entering the unit, the desiccant is overwhelmed within months. Water vapor condenses on the interior glass surface. You wake up one morning and see fog between your panes. That fog is the death certificate of your insulated glass unit. The window is no longer insulating. It is no longer transparent. And in most cases, it cannot be repaired without replacing the entire sealed unit at a cost of $400 to $700 per pane before labor. For a typical home with 10 windows, full replacement runs between $5,000 and $15,000 on a house that may be 5 years old. The failure is not random. It is progressive and predictable. By year 2 or 3, in Florida's heat and humidity, or at high altitude in Colorado and Utah, where atmospheric pressure differentials add mechanical stress to an already compromised seal, you may see intermittent morning fog at the edges. By year 4 to 7, the fog is permanent. By year 7 to 10, the glass has developed mineral deposits from evaporated condensation, the unit is fully opaque in sections, and you have drafts appearing around a window frame that was supposed to last through half your mortgage. Now let us talk about who built this system and why it keeps getting worse. JELD-WEN, one of the largest window manufacturers in the United States, was acquired by Onyx Corporation, a private equity firm, in an $871 million transaction. JELD-WEN has closed multiple United States manufacturing plants in recent years and faces ongoing scrutiny over its production practices. The company operates on a piece rate labor model with production bonuses tied to achieving high line efficiency. At that production speed, helium leak tests, the standard method for verifying IGU seal integrity, are skipped. Sealant pressure is not verified unit by unit. JELD-WEN has faced OSHA citations related to its manufacturing operations. In a separate legal matter, the company settled a securities class action lawsuit for $40 million related to allegations of misleading statements about its business practices. Pella settled a class action in Illinois federal court for approximately $26 million over wood rot and window failure. Milgard faces ongoing litigation over warranty and performance issues. Here is what every one of these settlements has in common: no admission of liability, average individual payouts that do not cover a single window replacement, and binding arbitration clauses buried in the warranty language that prevent future class actions from ever reaching a jury. The Consumer Product Safety Commission has logged numerous window-related recalls over the past decade. Many fogging defects are classified as performance issues rather than safety hazards, which means no mandatory replacement program, no notification to homeowners, no repair fund, just a database entry. The warranty language deserves its own examination. When a manufacturer advertises a lifetime warranty on a double-pane window, that warranty covers the IGU seal against visible fogging. It does not cover the labor to remove the failed unit. It does not cover disposal of the old glass. It does not cover the installation of the replacement. It does not cover any damage caused by moisture that entered your wall assembly through a failed window seal. And it is prorated, meaning by year 5 or 6, the manufacturer's obligation may have already declined to 20 or 30% of the original unit cost. The Energy Star certification on the box confirms that the window met a thermal performance target on the day it was manufactured and tested. It does not certify how long that performance will last. There is no federal mandate for seal durability testing in residential windows. Code compliance, in this case, the International Energy Conservation Code requirement for a U factor below 0.35 in many climate zones, is a performance measurement taken at the factory, not a lifespan guarantee. Built to code means built to the minimum. It means the window performed correctly once in a controlled environment before it was shipped to your house. A significant portion of the components inside a window labeled assembled in the United States. The spacer bars, the sealants, the desiccant materials are sourced from overseas. The FTC's guidance on Made in USA labeling confirms that assembled in USA is legally permissible even when a substantial share of the components are imported. The vinyl extrusions may come from Mexico. The glass itself is often domestically produced. The critical sealing components that determine whether your window lasts 10 years or 30 may be imported. So what does a window that actually lasts look like? The engineering answer is specific. Marvin Windows, based in Warroad, Minnesota, and family-owned with no private equity ownership structure, produces the signature Ultimate Series using wood interior frames with aluminum-clad exteriors, stainless steel spacer bars instead of aluminum, and a dual seal system that does not rely exclusively on polyisobutylene. The IGU is designed for repairability. The sealed unit can be swapped without replacing the entire window frame, at a cost of $200 to $300 per unit if you catch the failure early. Marvin stocks replacement parts for many years after manufacture. Their IGU warranty is backed by decades of tested field performance, not a marketing label. Consumer Reports has tracked Marvin's reliability and rates them consistently above private equity-owned brands in the residential window category. A Marvin Signature Ultimate window runs roughly $1,200 to $2,500 per unit installed. A builder-grade gelled wen runs $300 to $500. The math on that price gap disappears the first time you replace the gelled wen IGU at $400 to $700 per pane. By year 10, the total cost of ownership on the budget window, purchase price, one replacement attempt, energy loss from degraded insulation, can exceed the cost of the premium window that never failed. If you are buying an existing home, look for windows installed before 2005. The pre-2005 Anderson 400 series, with its thicker aluminum frames and steel-reinforced spacers, represents decades of field performance that current Anderson production may not match. Those older units are worth preserving. If they are still performing, leave them alone. For new construction or replacement, demand the following in writing before any contract is signed. Stainless steel or Swiss Pacer warm edge spacer bars. Swiss Pacer has documented significantly lower thermal bridging compared to standard aluminum. Dual seal IGU construction with silicone secondary sealant. Repairable IGU design with documented parts availability, and a warranty that explicitly covers labor and installation costs, not materials alone. Inspect your existing windows annually. Look for edge condensation in the morning on cold days. Check the perimeter sealant where the frame meets the glass for cracking or separation. If you see intermittent fog that clears during warmer parts of the day, you are in early stage seal failure. That is your window to act. Literally, before the desiccant saturates and the unit becomes irreparable. If you are in Florida, coastal areas, Colorado, or Utah, move that inspection timeline up. Your windows are under greater thermal and pressure stress than the manufacturer's warranty was designed to acknowledge. Your windows were sold to you as a 30-year asset. The engineering inside that sealed edge was designed for far less. The warranty was written by lawyers, not engineers. The certification label measures one day's performance. And the company that built them has already been sued, already settled, and already gone back to the same production line. Stop trusting the Energy Star sticker. Start trusting the spacer material. Stop accepting the lifetime warranty. Start demanding the labor coverage in writing. A house is not a consumer product with a return policy. It is the largest financial commitment most people make in their lives. The glass in your walls should outlast the loan on your house. Not expire before it is half paid. Demand materials engineered for permanence. Reject the disposable substitute. Your equity depends on the difference.